So this section is very introductory and just a very general outline. So 1.1 we're going to fly by, and then 1.2 we'll spend more time on. The reason why I have you write these definitions down is just in case there is like a multiple choice question, just identifying vocabulary. So statistics is the science of collecting, organizing, analyzing, and drawing conclusions from data. So we will be collecting a lot of data in here and analyzing it. We could be calculating averages, standard deviations, things like that. Now, what I mean when I say the word data is just the values for a variable from individual observations. So if I asked you a question and I asked you to report me a number or something, that would be considered the data. So if I said, how many pairs of shoes do you own? And you told me 23 or something, 23 would be the data. I said, how many wrecks per week are at the intersection outside? It could be 0, 1, 2, however many. A population, when I talk about a population, that's the entire collection of individuals. So a population can be whatever you want it to be. We could say a population is in here. We could say a population is PCA. We could say the population is the whole world. So you can really define a population to be whatever you're wanting to find information about. We are going to skip sample really quickly and talk about whenever we're collecting data about the entire population, what do you think we would call that? Census. Good. So a census is usually not a very good idea, and I'll give you an example of why. And this is not in your notes, but we'll just talk about it. So suppose that we wanted to, I guess the pop-up is there. Suppose we wanted to know the average GPA of high school graduates in the entire nation. That's what it says under there. And so we wanted to know every single high school in the whole nation, the average of all of their GPAs. So we would survey every high school in the entire nation, private and public. Why would we maybe not want to do a census here? What are some things that could happen? Somebody could lie, exactly. So
be different school districts, so the quality of education might not be as good in certain areas, which would result in lower GPA.
Yeah, so there's like different scales, different like economic statuses or types of education levels. Do we think that everybody is going to respond? So if I just generally send an email, a casual email out to every principal or every counselor at every high school, like if an email was sent to Dr. Moss, do you think he would immediately respond, or would he maybe like kind of forget about it? Do you think every single person is going to be on top of it? No. So people may not respond. So therefore, like it may not be very accurate. If you're trying to get a census, it's not going to be very accurate. Also, it's just kind of difficult. it's going to be really hard to go out to every single high school and gather all of that data. And if I'm the person that's running this survey and I'm paying somebody to go out and do that for me, then that could be costly too. So trying to get a census for every single person in the nation or something like that, it's usually not a good idea. It's a better idea to take a sample. So if we didn't perform a census, we could gather a sample, which a sample is just a subset of the population. And it can be organized any way that we want it to be. So can somebody think of an example of how is a way we could sample like 50 high schools in the United States? What's one way we could organize it? Well, how is a way we wouldn't survey every high school, but we'd only survey some of them?
One per state.
One per state, perfect. Can anybody think of another way? Yeah, one per region.
One from different levels of each level, like if you have different level schools.
Yeah, so like one per, or like some per status, I guess.
Like different economic areas.
Yeah. So you could divide it by economic levels.
Random?
Yeah, you could literally just use a random number generator and do it randomly. And we'll learn sometimes that's the best way to do it, because if you're not separating them by everything, if you're just randomly doing it, then you're more often to get an accurate depiction of what the true GPA is. The first thing is you want to realize like what the context is of the situation. So what does the data represent? And also, what is the goal of the study? So before you start anything, what is your overall goal behind the study? The second thing is, where are you getting this data? So what is the source? Is the source reliable? Or is it biased? And we'll talk about what biased means next class.
If something is biased, does it automatically mean it's not reliable?
Mm-hmm. If you have biased data, then it's not accurate at all. You just throw it out. And then the third thing you have to think about is the sampling method. So how I sample, is it unbiased? And then sometimes if you see studies, like if you're watching a commercial for this new medication that's supposed to help with a certain disease or a certain condition, and you see like 4 out of 10 people, or that's not even a good number, like 4 out of 7 people said that this medicine improved their symptoms or improved their condition. If you read the fine print, sometimes, like I was watching one the other day, and it said that these people were volunteers. And so whenever you see that someone is a volunteer, you're not necessarily going to get accurate data because they're wanting to be a part of it, or they have different views. Like you're not getting an accurate depiction of everyone that has this symptom. You're just getting the people that, and sometimes you can have a placebo effect, like they think they're getting better and they're really not. So you have to look at all angles, and this class is really going to teach you to be able to read a study and decide if it has any bias or not. But a lot of the articles that you read and a lot of the commercials you see and just things that are advertised, they're always kind of spun in a way that's going to favor themselves, and it may not be completely accurate. So you have to read the fine print. The next part is analyzing. So once you finally have your data, what are you going to do with it? First thing you're going to do is graph it. The second thing is explore. So once you have your graph, are there any outliers? What are the important aspects? So maybe like, are you looking for an average? Are you looking for a range? Something like that. What is the shape? Is it skewed, symmetrical? We'll learn about all that. And then finally, did any subjects refuse to respond? So that's a question you could ask yourself. Like, did anybody just choose not to answer? And that could skew your data as well or bias it. Once you have those things, you will apply statistical methods, and that's something that we'll do second semester mostly, but we'll use technology to run tests. That's what our calculators are for. And then lastly, we will conclude whether this study had statistical significance or if it had practical significance. So the difference between the two, so statistical and practical. So what statistical significance means, and at the end of the year, you'll actually go through this entire process and you'll have a study for yourself. So one of the studies from last year, they asked, like, what is the average amount of cash that people have in their pocket? And they, like, hypothesized that people don't really carry cash anymore. And they just thought, like, I'm sure the average is less than $10. And so they ran this test and they went to the cafeteria and asked a bunch of people, and like one person had $400 in their pocket, so that kind of skewed the data a little bit. But they found statistically, since we had that really big outlier, that it wasn't, like, she didn't have enough evidence to prove that people have less than $10 in their pocket because of that one outlier. So all of the math didn't really add up whenever she did the entire project, but by just practically looking at it, most people carried less, like $0, and then that one outlier kind of messed everything up. So it wasn't statistical, but it was practical. Sometimes you just have to use your brain and just look at it and say, okay, most people only had $0 to $10, but that one person that had $400 kind of messed everything up mathematically. So statistical is more mathy, like math-wise, and then practical is more of like, what is my head telling me? What are my senses telling me, kind of. So we're going to look at some examples, and we're going to decide whether, or we're going to identify what the population in the sample is in this study. So for part A, and we're just going to circle them and then draw a little line out to the side and say what it is. So the first one, it says the Gallup organization contacts 1,028 teenagers. So that's one of them, who are 13 to 17 years of age. And they ask whether or not they have been prescribed medications for any mental disorders, such as depression or anxiety. So whenever they contacted these teenagers, would that be a sample or would that be the entire population? Sample. And what is the entire target of people that they're trying to gather information about? 13 to 17 years. So all teenagers that are 13 to 17 years of age. But the sample within that is just the 1028. Okay, B. A quality control manager randomly selects 50 bottles of Coca-Cola that were filled on October 15th to assess the calibration of the filling machine. So what would the sample be here? 50 bottles. And what is the entire population? Yeah. Coca-Cola, just Coca-Cola bottles in general. And you could even write out to the side all Coca-Cola bottles, because it doesn't really say it in the sentence, so you could just write it out to the side. Yes?
Going back earlier, when we were exploring the data, there are 5 bullet points and we only went over 4.
Yeah, I only just did 4 of them, so you don't need the 5th one. Okay, I want you to try C and D on your own or with the person next to you, and then we'll come back together. So for C, the sample is the 100 plants, and then the population is all of the plants that the farmer's crop. D, the sample is 50,000 households. The population is all of the households in the United States. And then E would be the 128 students would be the sample. And then the population would be what? All full-time students. Population.
Because it's not
But they're,
full-time students.
yeah, it's just talking about the full-time students. So they don't care about the part-time ones, they just care about the full-time ones. Okay, 1.2, we're gonna get more into what the different types of data are. First thing is when I say the word parameter, I'm talking about the population, but within that population, they may report a number with that. So it's the number associated with the population. When I say the word statistic, it's the number associated with the sample. So we're going to read some context of either a study or a situation, and we're going to pull out the numbers that we see in that paragraph. We're going to decide if they gave us a parameter or if they gave us a statistic. So let's look at A. It says the comptroller of Texas wants to know how she will do in the upcoming state election. She hires a consulting firm. They polled 3,150 registered voters. The consulting firm finds that 57%, so there's one number, of the polled voters will vote for her. It turns out that after the election, she wins with 60% of the vote. Identify the parameter and statistics. So which one goes with the sample, the 57 or the 60? So 57% is a statistic. And then the 60% would then be a parameter. And why is that a parameter? Yeah, it's like the actual vote that everybody voted in. We hope everybody voted in. Maybe not. Okay, let's just do B and C and then we'll be done before lunch. Part B, following the 2006 national midterm election, 18% of the governors of the 50 United States were female. Would that be parameter or statistic? Yeah, it'd be a parameter because it's the entire Like out of all of the governors of the 50 United States. So that is my population. All of the governors 50 of the 50 United States. If it said we sampled 25 of them and 30% were female, then that would be a statistic. Okay, and then C, the average score for a class of 28 students taking the calculus midterm was 72%.
Parameter.
Why?
It's the
Because
same
it's
as
the
last
whole
one.
class.
No,
But it's just saying a class of 20.
Yeah, this is my population.
It's not saying 14 of 28.
So, and also you're assuming that there's another calculus class, but you don't know. So, for all that it's given me, we just think, all that we know is that there's 28 students in this class and we're not caring about anyone outside of that. So, if I said like 2 out of the 13 classes, the average was a 72, then that would make it a sample. But this would be a population. So the next topic on 1.2 is talking about 2 different types of variables. So we have qualitative and quantitative. I will always refer to them as categorical and numerical. But if you want to write out to this, I think it has it in parentheses. I would just circle those. But sometimes on my math lab, they call it qualitative and quantitative. So just remember both of those. What? Probably qualitative, quantitative.
We used to do an assignment on my math lab.
Not yet.
I never get into it.
We'll talk about it later, but not yet.
Alright.
And then within numerical, there's 2 types, discrete and continuous. So a categorical variable or qualitative identifies the basic differentiating characteristics, like it's categories. So if I ask you your favorite color, if I ask you what color your car is, one main thing to identify a categorical is that it doesn't make sense to average. Because you can't just say that categorical is just words and not numbers. Because there are examples of things, of numbers that are categorical, things that you would report that don't make sense to average. Like if I asked all of you to give me your area code of your phone number, so like your 214 or your 972 or I'm 903, would it make sense to average all those numbers together? No, because I would put you in categories. So here are the people that are 214. Here are the people that are 972. So area code would be an example of a number, but it's still a categorical. So you just have to ask the internal question, does it make sense to average? If it does not make sense to average that, then you would say it's a categorical. A numerical, quantitative, it does make sense to average these. So your height, your weight, number of pairs of shoes that you have, things like that. I'm trying to find the average. What is your GPA?
4.2.
Thank you. So let's look at these examples and tell me whether you think it is categorical or numerical, or I guess qualitative, quantitative. So A, nation of origin, Marie born. Qualitative or categorical. You can write either or, I do not care. Number of siblings, quantitative. Grams of carbohydrates in a donut, quantitative.
Numerical.
Perfect.
So for the test, can we just put numerical?
Yeah, I don't care. Either or. As long as you know that they are the same thing, then I will not penalize you. So within numerical, there are two types. The first one is discrete numerical. Think about that as something that you count. They're like isolated points. Like I can count the number of people in here. I can count the number of desks. I can count the number of chairs, count the number of calculators. So things like that you can't break down further and further. So I would just write in like all caps, you count discrete. And when I refer to something that is continuous, it would be something that I measure. So I measure my height, I measure my weight, I measure time, I measure distance, I measure volume. And those are all things that I can keep breaking down further into smaller and smaller increments. So if you think about time, I could measure time in days, hours, minutes, seconds, milliseconds, and I could just keep going smaller and smaller and smaller. But with something that is discrete, I can't keep breaking down people. Like I have one person, I can't go any smaller than that.
Number of usually, does that mean discrete?
Usually, but I don't want to say always, but usually.
Statistically, it's probable.
Okay, so examples. Runs scored in a season. Discrete, because I can count it. Volume of water, because I measure it. And then length in seconds of a country song. Good.
I think that might be continuous.
I think you might be right.
Thank you.
Almost done.
Okay, these are not on there, but let's just say them out loud. Color of cars in the teacher's lot.
Which one are we doing?
And this is not just discrete or continuous. This is now qualitative.
Wait.
Categorical.
So now this is not on your notes. This is just, we're saying it out loud. Number of calculators.
Numerical.
Quantitative, numerical, and then discrete. Zip code.
Qualitative.
How come?
Because, yeah, you can average it.
No, you don't want to average that. That would be weird. Amount of time it takes students to drive to school.
Yeah, continuous.
Continuous.
Continuous because time.
Time.
Do we have to say
Measuring
numerical or
time.
say continuous or discrete?
No, you could just say discrete or continuous, and that assumes that it's numerical. Because time, you can keep breaking it down. You measure time. Okay, last one. This one is tricky.
Quantitative.
Definitely
And
that'd be
Not categorical.
continuous numerical.
Continuous
numerical.
Continue.
You can average it, right?
Do you count money? You measure money.
You measure money.
You count
You count money. You count it. How? What is the furthest you can break down money? The very furthest. A penny. Can you go any further than a penny? No. So it is discrete. Money.
Yes. Where on time you can't go anywhere less than a second.
Yes, you can.
One.
Yes, you can. So make yourself a note out to the side. Money is always discrete. Money is always discrete. You count money. You don't measure it. And the furthest you can break it down is a penny, so you can't go any further. Okay, the last thing that we'll look at for types of variables is knowing the difference between, and I found this little graphic that I think kind of helps organize it. So what I want you to write next to the definitions are these things. Once you've written those down, then I'll kind of explain a little bit how to identify. So here's a visual that I think kind of explains it really well. And if you want to write this down, ratio should be, I guess it didn't copy all of it. Hold on. So here's all 4 of them in, so the context is a race. So in a race, everybody's assigned a number. And like, it doesn't make sense to average like what number you are. Like, everybody gets a little bib with their number on it. Doesn't really make sense to average those, so it's a categorical variable. And also, there's really no ranking. It's just according to what time you signed up. So if you're the first person to sign up for this race, then you're 1. If you were the last person to sign up for the race, then you could be like in the thousands. So there's really no ranking amongst them. Another example could be like color of M&Ms. That's a categorical variable. Maybe internally, like red is your favorite color of M&Ms, but there's not a ranking system for the color of M&Ms. So that's, when there's no ranking, that's nominal. Then whenever we talk about ordinal, it's still categorical data. You're in first, you're in second, you're in third. So these are both categorical. But now there's like a natural ranking. First did best, second was in second, third was in third. Then when we get to interval and ratio, these are numerical. So maybe somebody rated your running ability or how good you looked running, I don't know, on a scale, and you're comparing yourself with others. So interval is compared with others. And then ratio would be your time to finish, which is like compared with 0. Like, it's kind of like a race against yourself. So the thing that I see most often is people confuse interval and ratio. And the internal question that you just have to ask yourself is there a natural starting point? With like time, with distance, volume, things like that, they all like start at 0. So the natural starting point is 0. Those, that would be something that's ratio. Things like interval would be ratings, comparing yourself with others, scores, things like that. So let's look at, I think there were a few examples. We already talked about the color of M&Ms. What did we say that one was? Nominal. And the second one says the author rated the movie Star Wars with 5 stars on a scale of 5 stars. Is that numerical or categorical? Categorical because it's stars.
So it'd be ordinal.
Ordinal. If you took, and so this one I think is sometimes up for debate because you can also average stars. So you could think about, if you thought about it as numerical.
Yeah, that's what I like. You can still average, like.
Yeah, so you could take it into 2 interpretations, and sometimes, like looking at a set of data, you can either think about, okay, I'm going to put it into categories of 1 star, 2 star, 3 star, 4 star, 5 star, or I can think about it as 1, 2, 3, 4, 5, and I'm going to average them. And there's 2 answers for this kind of question. If I looked at it in more of a categorical sense, then it would be an ordinal because it does have a ranking. If I thought about these 5 stars as numerical because I'm going to average them, then what kind of not between nominal, ordinal, interval, or ratio, what would that be? Would I be comparing this with others, or would I be comparing it with just 0? Like if I'm looking at this movie just by itself, and it's not amongst all movies, like if I'm just looking at it by itself, it would be ratio. So it has to be, and the questions will be very specific. Just think about, am I comparing this with others? Am I just looking at itself starting from 0? But these problems will be pretty specific in the context clues that they give. But like I said, the most commonly intermixed is interval and ratio. So you just have to think, does it start at 0 or am I comparing it with others?